Hello and welcome to 10C. This is talking about coastlines, and it actually turns out that this thing that I said was down in Galveston is actually Assateague Island. So this is in Maryland, just a continuation of OBX, which would be down here in North Carolina, all the way up the coast, and you can see it just keeps going up. And as again sea levels rise, this will continue to migrate. So you can see there's the ocean, the dune, there's the marshes, the high and the low, and then we finally have a lagoon, which is the intercoastal waterway. So the Atlantic coastline is very well protected by this barrier island. Barrier actually is protecting it from like hurricanes, storm surges, may not make it over the dune, and even if they do, they've lost a lot of their power. Usually remember this is a passive margin where we have a very large gently sloped continental shelf as opposed to the active margin which has a very short, very steep continental shelf, and this is going to give rise to basically the two coastlines that are on North America and pretty much any continent. So mainly submergent. So what it's actually usually controlled by oceanographic principles, and it's actually submerging. We have barrier islands for protection, glacially shaped, like the Chesapeake Bay, and we have eroding coastlines where the oceans are actually taking the sediment and moving them farther out into the ocean, as you can see right there. And subsidence in most areas. Most areas, this is actually being covered by either an ever increasing sea level or it's actually sinking because it's a wetland and we put stuff on top of it and it actually subsides. Then we have the Gulf Coast. Gulf Coast still has a barrier island. The ocean, or excuse me, the Gulf would be over here. And then we have the continent over there protected by coastline or a barrier reef. It still is a passive margin. Mainly submergent, barrier islands, Mississippi Delta, that bird's foot thing that actually is coming out of there, fluvial, uh, large fluvial influence, very little oceanographic influence. High rates of erosion, tectonic subsidence. It still is subsiding because of weight. And then the Pacific coast is mainly emergent, where we have the convergence. So we have the North American plate being pushed up and the Pacific plate being thrown down under. Less erosion because it's solid rock. It's not sediment already. Mainly a rock shoreline, very tough to find beaches. Dams and rivers are stopping sediments from coming down, so we do get these cliffs forming as the rock actually gets eroded away, and it is tectonically active area. That's why it's called an emergent coastline. Coastlines of the United States, actually erosion. You can see Alaska's losing 2.4, 2.4. I don't see a unit on here. Okay, so let's talk about meters. So it's lost 2.4 meters, and you can see the West Coast United States average is about 0. We lose some and we gain some. And then the Atlantic is actually losing, although there are some places that are actually gaining. Talks about clastic sedimentary rocks, so that actually is like sand and rocks and pebbles. And then we also have limestone, which is calcareous. And then we have crystalline igneous rock, which is actually going to be basically lava flows or glacial evidence where it's the glaciers have taken away all the sediment and leaves a nice rock coast. Then hard stabilization. We can, if we notice that sand is disappearing, we can throw these what are called groins. This is a groin field, and you can see one side gets sand. This is the long-term current is coming this way and depositing sand up. And then there's no sand coming this direction, comes up the next time, picks up the sand, and then washes it up. And Jones here sees that Smith is picking up a new beach, so they throw up another groin, and cities can do this also. If they actually took these projections out, we'd find out we'd have an ocean beach line that would be, similar amounts of sand. Here we actually, if you've got a house too close, the sand that comes up here, the house could actually fall in. Perpendicular to shore, so it goes out perpendicular to the coastline. Trapped sand between the groins. Here's the original coastline, and then we actually find out that the sand accretes on one side and erodes on the other side, and we get the same amount of sand, we just move it into different locations. Interrupts longshore current. We can also throw jetties. If you have a place to an inland through the barrier islands, we can throw jetties out there, which would actually trap the sand from going both directions, because the problem with having one of these intercoastal waterways, having entrances every once in a while, if you don't, you're going to get a spit to form, a depositional environment to form, and it'll actually cut off the flow or fill in the channel, because deeper water is where you actually accumulate sand. So we throw these jetties up there to protect harbor entrances. Sand on the upcurrent side, so I actually see lots of sand, lots of sediment in there too. I can't tell which way the longshore current is coming. I still can't even tell. Maybe it's actually coming this direction, and I don't know where this is. I don't remember. We can also throw breakwaters up. Breakwaters to stop the waves. It breaks the water, and you can see this harbor wants to keep deep, so you put up this concrete or stone wall with concrete or stone wall up there. This one looks like it's a concrete wall, and it'll keep sand from getting in, waves from getting in. You have to have an entrance, so you probably put jetties up there to protect it, and you will have to dredge it out every once in a while because sediment will get in. These are usually parallel to shore. There's a perpendicular part, parallel to shore. They're usually offshore, so they're in the deeper water. Deposition behind the breakwater. So we actually get deposition back down here because it's deeper and less energy. And then we have seawalls. So here's the seawall, and you can see the seawall stops the waves, but what happens is it actually starts cutting down the sand that's in front of it, and eventually the wall breaks, and then the beach goes. It's built on the beach, parallel to the beach, erosion enhanced on the seawall side. So we actually have on the sea side, the erosion is enhanced, and the seawall gets destroyed, and the beach gets narrowed. So you can see a relatively thick beach before they put it up there. Seawall goes down, beach gets narrow. And I'm going to click here, and this is another thing that Apple will not work. And if you take a look at this, it'll actually talk to you about the coastline. So here's the coastline. Then we do overview, where we talk about the sand, and we talk about the foreshore, the backshore, the shore face, the offshore, the low tide line, the high tide, normal baseline. So it comes up, and from there on out, we're going to start getting erosion. And the high water line goes there, so you can see the difference between where the tide is for low tide and where it is for high tide. But what I want to show you is the model. So here's Mr. Smith and here's Mrs. Jones. They both have pools. They've got roads and driveways that come in, and then they built their houses, and they have nice green grass. So let's take a groin and let's put it right there. Actually right there, because what we want to do is we want to trap the sand, and you can see it doesn't let me put it any other place. Actually, there's a place, and if I do start, so what I'm doing is I'm trapping sand on one side, and you can see I've got accretion trapping it, and I'm actually eroding it, taking it away on this other side. So Mr. Smith doesn't like that, so what does he do? He puts one there, and now he's picking up sand, and now Mrs. Smith doesn't like it, so she puts up one here, and eventually we get this accumulated wedge on one side, and then we get this cut area on the other side. And then if we actually go back to reset, let's put up a seawall. Oops, in the wrong place. Oops, in the wrong place. Oops, in the wrong place. Where the heck do they want us to put it? Remember, seawalls touch the beach. So let's start it. And then we got longshore current coming this direction. It gives us deposition around the seawall. It's not really showing the undercutting in this section. It's actually saying that I get a little bit of sand on both sides, and then Mrs. Jones loses it again. And then if we do a breakwater, does Mrs. Jones want it? Mr. Smith want it? Let's start with Mr. Smith. And you can see the waves actually fan out from this location, and what that does is it throws it like a timbalo. It throws the sediment into these peaks. Reset, breakwater, give it to Mrs. Jones, and she gets the same thing. Okay, and I'll put that shockwave in the comments. Alternatives to hard stabilization. We limit construction near the shore. That actually is going to allow the sediments to accumulate naturally rather than digging them up for foundations and things. And then relocate businesses and homes that are destroyed by wave erosion. You can also plant seagrass. This is called sea oats, and these are two pictures that I took, I think. Um, these could be from somebody else, but I think I put these in there 2-3 years ago. But anyway, you put sea oats, the roots go in and they tie down the sand, so when wind comes through, hurricanes come through, it's less likely to move the dune. Remember, the dune is actually there to protect the rest of the barrier island or maybe your house. So you do want to get to the beach, and what that does is that compresses the sand and kills the sea oats. So you really want to minimize the amount of place. So when it actually says stay in areas that are made to walk to the beach, please do so. Don't walk over the hills because you will kill the sea oats and their ability to hold the sand. And that's the end of Unit 10. Appreciate you stopping by. Adios.